Welcome to this tutorial where we're going to see how vehicles can be used to transport entities inside SIMIO. So we place a source, a server and a sink in our model. And now we place the sink a little bit far on the right hand side because in this model we are supposed to move an entity between the server 1 and the sink, which is the path that we are drawing right now, through the use of a vehicle, of a truck. Why? Because in fact the model entity that we are moving in this process is a rock. And these are not very comfortable to be moved by hand manually. So we need a vehicle, we need a transporter. So we are going to introduce into the model by dragging and dropping an item which is called a vehicle. This is a very standard item in the SIMIO library. We call it a truck, and we give a strange icon that you see on screen just for now. So what are the properties of a truck we should keep an eye on? So we click on the truck and we see quite a lot of properties we need to set up. First of all, we need to set up the initial ride capacity. How many rocks can we carry inside the truck? Let's say that these are 20. And then there is something that is called task selection strategy. We pick the first rock in the queue. That's okay. We have some time, loading time for each rock. Let's say that it takes 5 seconds per rock. And then we have an unload time. That's going to be a little bit quicker, 1 second per rock. And then we have to decide if to park when we load and unload. Well, probably yes. And then we have some minimum dwell time. What is this? Well, one rule is that we are gonna wait until the truck is full before we move everything to the sink. Desired speed, well, this is 25 kilometers per hour. We can set it pretty easily under the travel logic. We move only across the network, which is across the paths we create into the model. We use the global network, all the network that exist, all the paths that we draw. We can select only a few of them. I mean, turnaround time, it doesn't really matter. Free steering behavior in the free space. Well, let's say that we have a delay of 0.1 seconds and we try to avoid collisions. But these are not really important parameters. More important is probably the routing logic, but we are going to see later. Just try if a model works. We set in a vehicle, we generate some entities, and the vehicle doesn't seem to do anything interesting. But we drag and drop the vehicle into the model, so why is SIMIO not using it? Maybe it has to do with the routing logic. We didn't touch it, we went pretty fast, and here we have a few things called priorities, etc., etc. And probably we need at least a place where to park the truck. This is one of the items in the routing logic, which is called home. We drag and drop a basic node from the standard library, and we connect it to, for instance, the output node of server number 1 through a path, and we use the parking truck node, which is just renamed, as the home of the truck. So the initial node in which the truck is to be found is the parking. Maybe that's the reason why things are not working, because we need at least a place where the truck should start and we should be connected to the path. Very likely, but it's gonna be enough, we don't know. So for now we just add this home node and we run the model. And no, it didn't work out. Still the truck is not moving while the entities are traveling to the sink. So why is that? So the basic reason is that nobody told the model, told SIMIO, that we should use the truck. We just drag and drop the truck. If you click on server number 1, nothing makes you think that you need to insert anything there. But if you click on the output node of the server, one of the properties of a transport logic is ride on transporter, which is false by default, but should be true, and you should be able to select the truck as the transporter, the specific one, to be used in order to be able to move rocks. Does it work now? Yes. So the truck is moved to this node. It loads all these different rocks with this very strange icon, and after a while, we don't have very much control, to be honest. It goes somewhere. I don't like it. We don't have any control to see if there are 20 rocks or 5 rocks or whatever. First of all, maybe I try to make the rock a little bit smaller with a different color, so I can see if that they are loaded correctly. And then I probably need to enlarge this green line, which is the line that houses all the rocks that will load on the machine. Quite intelligently in SIMIO, you can shape this line in the way you prefer in order to be able to visualize, for instance, all the rocks in this case. So we can use a zigzag line, like in this case, in order to be able to accommodate all the items, all the 20 items we should be able to see in the simulation. So you get this zigzag pattern on the track. But at least now you can see that the rocks are loaded. Well, I didn't choose the best possible color, so I'm gonna change it later on again. But at least now you see 20 items being loaded, transported to the sink, unloaded, and then nothing more happens. So why does the truck stops at the sink? Why is it not coming back? Well, this has to do with the way we draw the paths. So if you see path number 2, this is unidirectional. It goes only one direction. We should be bidirectional, in fact. We should allow the truck to come back, because the truck, as we defined it before, is following the network only. So it can only travel along the paths. So if you don't have a path coming back, well, that's totally impossible for a truck to perform a job. We can also do something else. We can also connect the parking to the sink and make it a bidirectional connection. We can also connect the parking with server number 1, make it bidirectional. And in this case, I will change the color of the rocks so we can see them a little bit better on the truck. We don't see them very well on the white background now. Okay, let's use yellow for a second and we change it again. So now we see all the rocks are loaded. Slowly, we go a little bit quicker. And now things are coming back. Very good. So now we load more rocks and we go to the sink and we unload them. Very good. So now we do it again just to check. And now, did I see it right? Did it? Okay, unloading at the sink. That's correct. I see that it was unloading, in fact, at the parking node. Yeah, but it's doing that. Why is the truck unloading at the parking node? Okay, what's going on? Well, we can solve this issue pretty easily. It's a common issue. We need, when you work with trucks, to define the entity destination type. So if you click on the output node of the server, if you look under routing logic, there is entity destination type, which is a property, but should be changed to specific, meaning that we need to deliver at this particular node, the input to the sink. So when you go under entity destination type, you change the node name and you get only the node you are interested about. Otherwise, very much SIMIO is going to use every node which is connected to the output node of the server. If you do that, now you load your 20 items and you're 100% sure that they are going to be delivered at the sink, and the parking will only be used as parking. Otherwise, SIMIO is going to use both. So now, perfect. That's a pretty decent model, right? So we can fast forward the simulation for a while and see what are the results. If we fast forward to the end of one day, we can select the vehicle and we can look at the statistics. So essentially, we use the truck 99% of the time, which is quite a high utilization rate. And the truck traveled a distance of 6,232 meters. Why? Where does this information come from? Well, this information comes from the length of the paths. We didn't set any length. But if you look at what is on the background of the facility view, there is a grid. And every square in a grid is 1 square meter. Is it true? Is it wrong? Well, we can change that in order to insert more realistic data. Let's say that the distance in a real mine between the server and the sink is 400 meters. We can click on a path and we adjust the logical length. We change the parameter drawn to scale to false, and we set the logical length in meter that we think is the most correct one. So drawn to scale is set to false, otherwise we take the pattern, square pattern on the background as a reference. And now we have the real distances. I can also choose to apply a different symbol to the rock to make it more more like a rock. There are some predefined symbols in SIMIO, but there are no rocks, unfortunately. I can import one from my computer. I have in fact an icon, a 3D model of a rock that I downloaded many months back. I search on my computer for rock, and I have in fact something that is called rock.obj. OBJ is the file that SIMIO uses in order to create 3D models for the simulation. When you import a 3D model like that, you get this view, 2-dimensional or 3-dimensional. You choose here on the left hand side. This black thing is the rock. It has the shape. You can rotate it to make it look more like a rock. Its length is 994 meters, so more 1 kilometer. Rock is more like an asteroid. So you can in fact change the width and the height. So I will make it half a meter larger and a little bit smaller, so I can see them being loaded on the truck. When you are happy with orientation and the size, you can go back to the model and, for instance, give it a color which is significant. I will give the rock this gray color. Now it gets quite a lot of nice shades. It is looking like a rock, in fact. Now you see, we are loading our rocks. I should probably make them slightly smaller to be able to see them loaded, all of them, on the truck. And I can now deliver the rocks, and things are loaded again, and things are then delivered again in the right place. But now, when does the truck go back to the parking slot? So you can decide that. Very simply, you can click on the truck, you can go down to the routing logic, and you can choose what is happening when the truck is idle and when the truck is off shift, when it's simply not working. Importantly, the logic by which we load the truck can be changed. By now, we wait until it's full, but we can wait for a specific time, for instance, for 1 minute, and then deliver the rocks and then coming back. This is what we do by changing the minimum dwell time. We set it to 1 minute, and now when we run the simulation, we notice that we are gonna load only 7 rocks, the rocks that are delivered in that 1 minute, and then we bring them to the sink. When we come back, we take more rocks, we load more rocks, more than 7, and then we get them to the sink, and so on and so on.